Good morning, dear students. Welcome again. I hope you all are fit and fine. Today again I am going to continue our chemical kinetics lesson. So today we have to understand first order gaseous phase reactions. You know very well, if reactions are in gaseous phase, in terms of pressure, gaseous phase reactions generally follows first order kinetics. So today my first heading is first order gaseous phase reactions. Suppose a reactant converted into B and C, that is A after heating to produce B plus C. All are in the gaseous phase, that is reactant and product both are exist in gaseous phase. Suppose initial pressure of A is P0. When reaction is not possible, that is only reactant is given, then pressure of product become what? 0. Pressure after time t, that is P0 minus P. P is what? Reduced pressure of reactant A. P0 minus P is equal to what? Pressure left. If P pressure is reduced, that's why P pressure becomes formed for B and P pressure formed for what? C. Therefore, total pressure after time t, that is Pt is equal to what? P0 minus P plus P plus P. Therefore, Pt is equal to P0 plus P. Therefore, P is equal to what? Pt minus P0. What is Pt? Total pressure, where Pt is equal to total pressure. P0 is equal to initial pressure. P is equal to reduced pressure. Suppose this is equation 1. We know that PV is equal to nRT. This is our ideal gas equation. If reactants and products all exist in gaseous phase, then our ideal gas become applicable. If volume and temperature are constant, then we can write what? Pressure directly proportional to N. So pressure is directly proportional to number of moles. Again we can say P is equal to N by VRT. If R and T are constant, then pressure directly proportional to what? Concentration. So for gaseous phase reaction, either pressure directly proportional to number of mole, or you can say pressure directly proportional to concentration. From first order kinetics, we know that what? K is equal to 2.303 by T log base 10 A by A minus X. What is A? Initial concentration. A minus X, concentration after time T. Again we can write K is equal to 2.303 by T log base 10. Instead of A, we can write what? P naught. Here we can write P naught minus P. Because concentration, or you can say mole, is directly proportional to what? Pressure. From equation first, we can write what? K is equal to 2.303 by T log base 10 P naught 2 P naught minus Pt. This is equation number 2. Putting the value of P from equation first, we get K is equal to 2.303 by T log base 10 P naught divided by 2 P naught minus Pt. This is our expression when this pattern of gaseous phase reaction is given. So in nutshell, we can say for any gaseous phase reaction, we can find out the value of K if follows first order kinetics. One important thing always remember, generally problem related to pressure, radioactivity, carbon dating process, problem related to bones, or you can say tree or wood. Such pattern of reactions generally follows first order kinetics. So we can write in note problems related to pressure, radio activity, carbon dating process, tree or you can say wood, bones, rocks, etc. follows generally first order kinetics. Let us consider some numerical problems which are based upon pressure. So our first numerical from NCERT 4.20. Our question is for the decomposition of isopropane to hexane and nitrogen at 543 Kelvin. The following data are obtained, that is given time in second and pressure millimeter of mercury. Suppose it is given 0, 360, 720 and here 35, 54 and 63. Question is calculate the rate constant. In this question, time and pressure are given. So if pressure are given, then our reaction generally follows first order kinetics. What is our equation? Azoisopropane. This is the formula of iso group. And this is said to be what? Azo group. So the formula of azoisopropane, CH3 whole twice CH, N double bond N, and again we can write what? CH3 whole twice. This is called what? Azoisopropane. This chemical exists in gaseous state. So according to question, when azoisopropane is given, then after decomposition it produces what? Hexane and nitrogen. So all chemicals are given in gaseous phase. So in terms of pressure, we can write down the first order kinetics equation. So our reaction become what? This is azoisopropane, exists in gaseous state, converted into what? Hexane. What is the formula of hexane? C6H14 plus nitrogen gas. Initial concentration, suppose it is taken a small a, then the concentration of product become what? 0. After time t, the concentration of azoisopropane A minus X, and here we can write what? XX. According to question, total concentration after time t is equal to what? A minus X plus X plus X, A plus X. According to question, we can write what? A proportional to our initial pressure 35. A minus X proportional, A plus X, that is said to be total pressure. A plus X proportional to what? 54, because total pressure is given. So we can write X proportional to 54 minus 35, that is X proportional to 90. So according to proportionality concept, initial pressure 35, pressure dissociate 19. We know that K is equal to 2.303 by T log base 10 A by A minus X. K is equal to 2.303. T is, if we consider 360, log base 10. Instead of A, we can write what? 35. Here, A, 35 minus X, 19. Means what? 16. A minus X is equal to what? 16. K is equal to 2.303 by 360. Log base 10, 35 divided by 16 is equal to 0.3400. It is calculative value. So again we can write, after solving, K is equal to 2.175 into 10 to the power minus 3 per second. Why we write per second? Because the unit of first order reaction is per second. So this is the numerical value for what? K. So our question is what? Calculate the rate constant. So this is approximate value of K for this type of problem. Our next NCERT problem 4.21. This problem is very important for your board examination point of view. So our question NCERT 4.21. The question is, the following data were obtained during first order thermal decomposition of SO2Cl2. SO2Cl2 is called what? Sulfuryl chloride at a constant volume. That is SO2Cl2 gas converted into SO2 gas plus Cl2 gas. It is called what? Sulfuryl chloride. Data is given, that is experiment, time in second, and total pressure in ATF. Experiment 1, 2, time 0, 100, pressure 0.5, 0.6. Always remember, total pressure is given. Then calculate the rate of reaction when total pressure become 0.6580. So according to question, first we have to find out the numerical value of what? K, that is rest constant. If K is given, then finally we can find out the rate of reaction when total pressure is given, that is 0.65. So according to reaction we can write what? SO2 plus Cl2. Initial concentration, suppose A 0, similar to previous one. Concentration after time t, we can write what? A minus x, here x and x. According to the concept of proportionality, we can write what? A proportional to 0.5. Total concentration A minus x plus x plus x, that is A plus x. So according to question, A plus x proportional to what? 0.6. Again we can write x proportional to 0.10. So from first order kinetics we can write k is equal to 2.303 by t log base 10 a by a minus x. K is equal to 2.303 t 100 log base 10. Instead of a we can write what? 0.5. Here we can write what? 0.4. Why? Because a 0.5, x 0.10, therefore a minus x 0.4. If we solve, we get the value k is equal to 2.303 by 100. Log base 10, 5 by 4 is equal to 0.0969. K is equal to what? 2.23. 2316 into 10 to the power minus 3 per second. So the numerical value of k is equal to what? 2.2316 into 10 to the power minus 3. If k is given, then we can easily find out the value of what? Rate of reaction. For rate of reaction, again we can rewrite our previous reaction, that is SO2Cl2 SO2 gas plus Cl2 gas. Initial concentration A00, concentration after time t A minus x xx. Total concentration after time t, we can write a minus x plus x, that is a plus x. According to question, a proportional to 0.5. A plus x proportional to, according to question, 0.65. Therefore, x proportional to 0.50. Therefore, rate is equal to what? K A minus x per power 1, because follows first order kinetics. Therefore, we can write k is equal to the numerical value of k 2.2316 into 10 to the power minus 3. Here we can write what? A is equal to 0.50 and x is equal to 0.15. That is 2.2316 into 10 to the power minus 3 into 0.35. If we multiply it, we get what? 7.8 into 10 to the power minus 5. And unit become ATM per second. So this is the numerical value for what? Rate. When total pressure is equal to 0.65 ATM. Okay. So in next lecture, we will learn our inertia equations and collision theory. Thank you.